very much, gents.
Perfect. Thank you very much.
That's it, Nick. Perfect. Now I shall mute everybody else.
So good evening, everyone, and thank you for allowing us to join and present to you tonight. This is a presentation on a first of a kind Class 170 less oil, cleaner exhaust project. We were kindly asked by Nigel Yule, so thank you, Nigel, for giving us the opportunity today. This project was a joint project fitted to an East Midlands Railway vehicle and funded by Porterbrook, the leasing company, as part of Innovate UK work streams. A little bit about Innovate UK. So Innovate UK is part of UK Research and Innovation, a non-departmental public body funded by a grant in aid from the UK government. Since 2007, they've invested around £2.5 billion to help businesses across the country to innovate with match funding from industries, taking the total value to somewhere around 4.3 billion. Can I please ask that any questions kept till the end, and many thanks. So my name is Nick Lamb. I'm a fleet engineer for East Midlands Railway. I've been with EMR for almost 3 years now. Previously worked for other train operators, including Wabtec as a an overhauler. I've been in the railway for about 15 years now, as I said. Completed my apprenticeship, my HNC, my HND, my degree. For this project, I was point of contact and lead for EMR. My duties were to deliver the project safely and on time, ensure the vehicle access was available, documentation was filled in correctly, attend all the meetings that everyone else had to as well, and ensure the vehicle was fit for service at the end of the project and delivered back to the railway. Ian, do you want to add anything?
I'll just do a brief summary of my career to date in the railways. Thanks, Nick. I joined the railways in 2000 with Interfleet Technology, as it was back then, and worked for them in a number of roles. Started off as a project engineer and then moved into the audits and safety team and headed up the audits team until around 2007, when I became head of business consulting. And I stayed with Interfleet until around 2014 and then joined Porterbrook, and I've been involved in a number of major rolling stock modification projects since then. And on this particular project, I was the PM for Porterbrook, and similar to Nick, I was managing the activities within our business and stakeholders, and reporting to Innovate UK, the main funders of this project, on the progress, and demonstrating that we were hitting the requirements under the funding agreement. Nick, you're on mute, I think.
Thank you. At least it's not being recorded. A quick discussion on the companies involved in this work stream. So East Midlands Railway and Porterbrook were the leads. Obviously, it was a East Midlands Railway train as the train operator, a Porterbrook funding body as they were the rail owning company of the vehicle. Eminox were involved as the exhaust after gas system and removal and installation of all their own equipment. It's important to get that bit in. Box Rexroth for the hydrostatic system, DG8 for the design, and DG8 contractor DEU for removals and fitments of the hydrostatic elements. So the project aim was to retrofit exhaust after treatment technology onto one of Porterbrook's Class 170 Turbostar vehicles, enabling mid-life diesel engines to rapidly become more environmentally sustainable, which addressed Theme 1 of the Innovate UK First of a Kind Round 4 competition. In doing so, we needed to install a lower capacity hydrostatic tank. This was to make room for the AdBlue tank, which needed to be installed, and potentially making a significant environmental difference. So the aim was to improve air quality by lowering emissions by somewhere between 75 and 90% and reducing waste oil by 84%. The purpose of this project was to assess the operational performance and emissions reduction achievable, as well as the reliability and maintainability of the new after treatment and revised hydrostatic systems. So in summary, the aim was to retrofit an exhaust system and technology onto a mid-life train with a focus on bringing down the emission levels in line with what you'd expect to see from a new engine. The opportunity arose, as we've said before, from the Department of Transport and Innovate UK. So this was a little bit on the project plan as it looked. So the timescales originally were somewhere, I think it was July 2020 to finish in March 2021. But obviously with the impact of COVID, we had a 3-month extension somewhere along the way. So the main project was broken down into pre-project, mobilisation, execution of phase 1, execution of phase 2, the closeout of the first of a kind, and then the Porterbrook closeout. So the actual closeout date was close to the 30th of June. This was due to some of the minor issues that we'll discuss later on. COVID affected the availability of the units to East Midlands trains as they were being cascaded down, East Midlands Railway. The timescales were very challenging on the design to start with. The equipment, the installation, the lead times in getting some of the equipment was large. So we set ourselves in a challenging environment, which ultimately, no spoiler, but it managed to be a great success. So a little bit about the unit involved, or the vehicle involved, should I say. So the vehicle that was chosen was a Class 170 Turbo Star, in particular unit 170-531, vehicle 79631. Built somewhere after 1999. Some were built by Adtrans, others by Bombardier Transportation. It's got a 13-litre 6-cylinder diesel engine with 422 horsepower per car.
Thanks, Nick. I'm just going to talk now about the two systems on the vehicle that were modified. I'll start with the hydrostatic system. You can see here a schematic of the existing system. The item we're most interested in is the hydrostatic oil reservoir, which you can see in the photograph on the right. It's a very large tank of around 200 litres capacity. And the purpose of that system is to power two major subsystems on the train. The first is an alternator pump, which powers the alternator and provides the auxiliary power on the vehicle. And secondly, there's a fan pump for the engine cooling fans. And both of those feeds return into a filter and then return back into the return portal on the hydrostatic oil reservoir. Just move on to the next slide, please. So the modification we were doing was to change the 200-litre hydrostatic tank for a much smaller tank that had been developed by Bosch Rexroth. And this technology had been used successfully in military applications and to some extent on rail vehicles in Europe, but it was certainly a first for the UK. As you can see in the first bullet, the two pumps had a flow rate of 100 litres per minute and 70 litres per minute. And the rating of the system we were applying was 350 litres. So it was more than comfortable with coping with that demand. The benefits were we were reducing the hydrostatic oil tank capacity to 16 litres. That's around 184 litres, saving 84% in volume and giving us significant benefits in size, weight, and oil consumption. So another benefit was that this would have no impact, or it was envisaged to have no impact on the maintenance of the train in this area. So 200,000 miles between oil changes. The schematic shows the new arrangement. It's very similar. We didn't touch anything beyond the fan pump, alternator pump, and back to the return. We simply added a suction manifold and a return manifold. That's because this much smaller tank doesn't have the ability to have two feeds from it. It can only cope with one. And you can see in the photograph on the right, that much smaller grey cylindrical tank there has replaced that large 200-litre tank, and the ones of you with keen eyes will be able to pick up that there's an AdBlue tank been added there as well. That was one of the benefits of this modification, is it allowed us to put in a key component of the exhaust after treatment system. Move on to the next slide. Thanks, Nick. I've just got a few CAD images of the design that was adopted, and you can see there the cradle surrounding the hydrostatic tank and the changes to the pipework feeding into it. The filter was pretty much the same. That's that vessel, smaller vessel on the right there, and the air reservoir you can see behind that was untouched. There's another CAD image afterwards which shows that a bit more clearly. You can see on the bottom left of the image on the left, the pipe is coming out of the hydrostatic tank and splitting at a manifold under the light blue cradle that you can see there, and then on the suction side feeding into the filter in the foreground. So those are the two major changes we made to the return and the suction inlet and outlet on the hydrostatic tank. The second system change was the exhaust system. We replaced the original silencer with an Eminox developed exhaust after treatment system, and it was developed to fit within the space envelope. And to aid that, Eminox carried out some 3D scanning on a Class 168 that was undergoing repairs at Wolverton, and used that information gathered to develop a suitable solution. It involved new support brackets, but the interfaces with the exhaust pipe and the stack, exhaust stack, remained the same. And the new urea and AdBlue tank was integrated onto the existing TurboStar alternator raft, as I showed you in the earlier photograph. Got some better images of that later in the presentation. And again, 3D scanning was used for that purpose. The exhaust after treatment system also included a urea pump, regulator and filter, and that was put on the opposite side of the alternator raft. And the air supply was taken from the main reservoir line, and the existing engine air filter was moved slightly towards the engine to free up space for that equipment. There was also a mass airflow sensor integrated into the engine air intake. That's a critical item for the exhaust after treatment system management. And a new pipe fabricated was fabricated to replace the original one with the mass airflow sensor already built in. There were no changes to the existing engine raft, which is crucial because it means that we're not creating another variant of the raft, and it's sort of interchangeable with the rest of the TurboStar fleet. And the final change was in the number 2 body end electrical cubicle. There was a control ECU put in there, along with an antenna for the telemetry system, a miniature circuit breaker and a relay. So relatively minor changes there, which didn't really impact on in any way in the existing arrangement in that cubicle. The overall impact of the changes, and I'm talking about both the exhaust after treatment system and the hydrostatic tank, was a net increase in mass of 134 kilos. That's in tear condition. So it was a relatively small change, and that didn't impact on things such as vehicle sway and put undue loading on the axles. It was all within the allowable limits, and that was verified by a third party. Just move on to the next slide, please. Thank you. And I expect many of you are familiar with how exhaust after treatment systems work, but I've just done a quick slide here for the benefits of those who may not be familiar with the technology. What you're looking at there is a schematic for an inline EAT system. This is the system that we used on a similar project we've done on a class 159 operated by South Western Railways. This type of arrangement fitted nicely into the exhaust silencer that we took off there. The turbostar is somewhat different in that the exhaust system is like a U-shaped arrangement. So the EAT system that replaced it is also a U-shaped arrangement. You can see after the Dpf substrate in the middle there in the mixer, we then put in the U-bend, so it turns back on itself at that point. But as a brief overview, you can see on here there's a number of sensors. We've got a mass airflow sensor that I mentioned earlier at the engine air intake, and also a NOx sensor at the inlet to the EAT system, and a number of temperature sensors along there as well, and a NOx sensor at the outlet. And you can see on the top of that diagram the urea injection arrangement controlled by an ECU, and the ECU takes feeds from those sensors and manages the amount of urea AdBlue solution that is injected into the exhaust after treatment system. But starting at the inlet, we have a diesel oxidization catalyst, and the purpose of this is to oxidize carbon monoxide and hydrocarbons into harmless CO2 and water. And following that, there's a diesel particulate filter that removes the majority of any remaining soot particles. And I think we achieved in the region of 90% with this arrangement. So that's a lot of harmful emissions taken out of the exhaust gases. And the next stage is to tackle the nitrogen oxides that are in the exhaust, and the mixer, as I mentioned, puts in the correct dose of AdBlue, which contains ammonia, and the ammonia then mixes in with the nitrogen oxides, and in the next stage, the selective catalytic reduction phase, this causes a reduction in the nitrogen oxides into water and nitrogen. And finally, there's a cleanup catalyst that removes any excess ammonia that hasn't been spent in the SCR. So, and then the gases proceed as they would on a normal turbostar through the exhaust stack and to atmosphere. Thanks, Nick. Next slide, please. And here you can see a CAD image of the exhaust system, the Eminox S5 filter assembly. You can see the U-shaped arrangement, as I mentioned, and the side nearest to us is the part with the selective catalytic reduction and the cleanup catalyst, and the other systems are in the far cylinder that you can see there. And this CAD image shows the arrangement for the other part of the exhaust after treatment system. You can see the 160 litre AdBlue tank or urea tank that's sitting next to the hydrostatic tank in the space liberated from the very large previous hydrostatic tank. We've also added some bracketry on above the alternator raft for this to be suspended from. And you can see on the left a pipe that runs to the filling point on the other side of the vehicle, which gives the flexibility you need for fueling points. And also there's a mounting frame there for the urea pump and the air set, and the repositioned air filter. There's a mounting plate for that adjacent to it. And this diagram gives you an idea of where this all sits on the vehicle. So we've got the hydrostatic tank and the urea tank amidships. And at the number 2 end, we've got the exhaust after treatment system. And in the number 2 end, electrical cubicle, we've got the control unit and the telemetry and so on. I'll hand back to you now, Nick.
So the EATS static was tested at LH on the 19th. I think I've got 2 slides on this. Between the 19th and 21st of January, with an overhauled raft on the back-to-back basis. It achieved the emissions reductions targets of NOx 75%, PM 90%, CO and HC 90% during runs. The NOx reduction of over 90% seen during particular runs. I'm going to explain it better on the next slide. So the test cycle was designed to evaluate the performance of the after treatment system, both in terms of emission reduction percentage and against the absolute limits of stages. When tested against the ISO 8178 C1 8 mode test cycles. An example of testing data is on the right hand side, and as you can see, the testing was a success and the agreed targets of mass emissions and reductions was achieved. The system, to be fair, it performed exactly how it was supposed to. The only note at the bottom there is, whilst the overall results meet the criteria set out in the first of a kind agreement, the idle condition was neither less impacted negatively on any of the results, so it didn't have any bearing really whatsoever. So now I'll try and explain to you a little bit about what happened on the week that we had to fit it, which was very tight timescales to say the least. So as you can see from the notes there were a few things that we were sort of planning on happening before the vehicle got to us on the Monday morning. Cascaded vehicle was supposed to be there, so I think it was the Friday or the Saturday. It actually didn't arrive onto Etches Park until Sunday evening, I think it was. So Monday morning, still in the middle of the pandemic, we had agreed with the depot to limit the number of visitors to 8 external guests. We cleverly arranged the teams of Bosch and Eminox to sort of opposite ends of the vehicle where they could. So obviously sort of midway along this side of the vehicle where the hydrostatic and the AdBlue system needed to be worked on, with the Eminox guys on the opposite side, removing the exhaust system and also on board in the cabinet ends. We use as much space on the vehicle to hold meetings for myself and Ian. We set up a little office in there. The tanks were drained, but not completely, leading us to drain the hydro oil, which didn't need to be drained, to remove the hydrostatic tanks and the other ancillary components. Removal of the old exhaust system. The Eminox team made brilliant work of removing of the exhaust system. The guys were all really good all week to say that we had COVID to work against. Obviously, we had short members of staff available on depot, which meant anytime that we needed a forklift, which I think we managed to get around, not needing one at all. But obviously, there's guys walking around all the time, and we're trying to give them as much safe space as possible. So Tuesday and Wednesday was just myself and Ian and a couple of onlookers from both of our companies watching what we were doing very carefully, whilst the Eminox team set to work. Wednesday, the Eminox guys, the installation activities continued. This was the exhaust, as well as taking the power feeds from inside the cab end, which we got our wrists slapped a few times for due to leaving swarf and the gangways open where we shouldn't have, and yeah, we got into a little bit of trouble. But thankfully, the unit was buried; it was safe. We managed to work around as best as we could. Also, the alternator raft by the end of the day, all the work needed to be completed. On the Thursday was the installation of the new hydrostatic tank. This included hand filling of the hydro oil. We didn't have a proper pump, so it was obviously the oil was prepared, or it didn't need to be preheated or anything, so it was hand pumped into the unit. I'll discuss some of the issues that we found with the hydro system a little bit later on. And then, skipped a slide. And then on Friday was completion of all activities and then a test run. The Eminox guys, if I remember correctly, actually completed on the Thursday evening at somewhere around 8 o'clock on their own. They were still busy away. But they had to hang around and wait until the Friday so that we could do the full testing with all of the hydro equipment also working, do the run-ups, do the testing under load and under power, get the compressor going, make as much noise as we could in the depot, which really, really impressed everyone. So we managed to get a nice run out on the Friday, which myself and Ian will show you some actual video footage of. to carry out a dry run. So this is a little bit about the week of fitting, the issues that we had, what went well, what didn't go well. One of the things that really went well was we had a lessons learned afterwards. So we got all parties back in. I think it was about a fortnight after all the activities had been carried out. And we all sat around and we talked about all the issues that we'd faced, how we'd overcome them, how it worked well. If we were to do this again, would we be able to replicate it? Would the results be the same? What would we change if we could change anything? So the test run was a success. That was brilliant. The fitting of the exhaust AdBlue system went really, really smoothly. One issue that we had, one slight issue, is when we were when we were measuring up the vehicles, I don't think there was a 170 available, so 168 was scanned, which had a very, very comparable exhaust system, but we had to make a couple of bits up on the week as the week progressed, some mounting points. Thankfully, all the materials arrived on time, so we had hydro oil, we had AdBlue, thank you, Ian. We had the exhausts, the hydro equipment, everything seemed to turn up as it was supposed to. That doesn't mean that it all worked. We had we not had some of the issues that I'll discuss in a little bit around the hydrostatic side, we would have completed completely on time. Some of the activities that we had with the hydro sort of delayed all the progress a little bit. All parties worked really, really well. They were there from the crack of dawn until late few evenings to make sure that we delivered on time, which me and Ian were both thankful for. And the communication between all parties was brilliant. So a few issues. Obviously, we had the COVID-19 pandemic, which no one could prepare for. Vehicle access was difficult at times. Obviously, you can't just go on and start a train up, even if you know how to. We have to go and follow the right routes. We had swarf contamination. So the hydrostatic tank had a swarf contamination issue. Luckily, we didn't manage to run the hydrostatic system up. What happened was we went to refill the hydrostatic tank after fitting the new one. So we filled it with oil and then noticed that the level sight glass was cloudy, which obviously means that there's possibly some sort of contaminant in there. So the Bosch guys, myself and Ian, agreed that we would drain the tank again. So we would we saved all the oil that we drained previously, but this we couldn't save. Unfortunately, one of the depot guys had left it outside and it had rained. So there was some element of water in there, which was really lucky because we wouldn't have found the swarf issue. So it appears that when some of the mounting holes were drilled on the hydrostatic tank, the swarf hadn't been completely flushed out and some was around the magnetic pump. So sort of a balancing act of didn't really want water in the system, but had we not had it in, we would have potentially ruined a lot of the components going down with metal in them. We had to order a new temperature sensor as the temperature sensor that we had was not compatible, resulting in the need to produce an adapter to connect the existing temperature sensor. We did the design review, carried out electrical interfaces, checked all the characteristics, managed to do it all whilst on depot. The adapter was made at short notice. We had to make one due to the size and type of thread. And for a fleet rollout, a new variant of the sensor would definitely be required and would be implemented, and we've already discussed that. We also had, so I think that was it. Oh, there was one issue with the low sensor, I think, which I'll come to a little bit later on as well. Obviously, with reducing the size of the hydrostatic tank considerably, I think it's now a fifth of the size or thereabouts. Obviously, that interacts with a lot of the other components. So you've got a sight glass, which would normally have min and max levels in there, and obviously a sensor in there for low and low oil. So if it's got low oil, the unit will still run. If it's got low, then it won't even turn on. So obviously that had to be changed a little bit. So this was our lessons learned. So I picked a few things out of this. We had a couple of hours on it, I think, if I remember, Ian, which was brilliant. Perhaps longer should have been given to carry out the fitment. I think if we'd have had 7 days rather than 5 days, we would have definitely come within the timescales that we needed to. I think we were very ambitious with a week. The teams that we had with us, we couldn't have got better teams. That was as quick as we could do it. We should have done more static testing of the hydro systems. We found a few issues along the way, which we should have picked up, but as this had been previously fit on another unit, as Ian mentioned earlier, we were fairly confident. We should have definitely checked and measured a class 170 exhaust. I'm pretty sure it's because one wasn't available on the day. This hydrostatic unit, hindsight, should have definitely been flushed out. And we also learned that it is possible to complete a railway project on time and during COVID. So this is just going to be a little bit of a conversation now about, I mean, it seems very, very easy to go and take some technology and go and fit it on a vehicle, but when it comes to the the level of documentation required to do that, it's absolutely amazing what goes on behind the scenes. So everything from following group standards like GMRT 2130 for fire, safety and evacuation. We had a hazard review, which was carried out, I think it was bi-weekly, a little bit later on. This catalogued and helped us to understand any issues with gauging dynamics, mass, electrical ratings, EMC, noise, temperature, standards, tooling, training requirements. We had to do engineering drawings. There were design freezers. We had to do further drawings during the week. We had to get an attestation statement. We had to do methods of work to show the depot exactly how we would be carrying all this work out safely so that the depot manager would agree to allow us to work on these units. We had to have engineering change and management of change, which isn't just one document. So Porterbrook had their own engineering change and management of change structure and folders. We also had our own, which goes through major, minor. There were technical bulletins sent out for the depot staff for awareness to make sure that they were aware that this piece of kit was shiny and new, not dirty like some other parts of the train. Also for the drivers, because obviously they're driving now, there's going to be certain potential issues. This is now carrying a lot less oil than before. So as we all know, as oil gets hot, it expands. Some oil might escape through a breather filter, which would mean that when the unit is left to then go cold and restarted again, sometimes the low sensor would have tripped, but it was all about awareness and training. So there was a lot of work, and the next slide is just a screen grab of just some of the documents involved in that, which I think there's probably 3 or 4 times that, plus packs of documentation behind. So this is just a little bit about one of the issues that we encountered along the way. Obviously, things don't always go as smoothly as you would like them to. So we had an issue with one of the level sensors and had to revisit the reservoir options that we had. So this included the min and max fill levels, as they in turn affected whether the low and low sensor would be tripped. This also affected how much oil was in the sight glass. The sight glass was actually a clean one, so you could actually see it, which would allow, as the depots are doing the checks, which would show you as a visual indicator that this unit needed more oil. We did try and think about all elements of design, but sometimes you can only actually find out how they're going to work once they're fitted. The current low level moved from 2.4 litres to 6.3 litres from the top. The new minimum and maximum levels are in red on the right hand side, along with the warning levels. And this was another one. So the installation of the trial Bosch hydrostatic reservoir and associated pipework was installed. The installation of the hydrostatic control box onto the Eminox AdBlue tank was not possible in the design position, as the new pipework clashed and the connector on the back of the control box, which you can sort of see circled in blue. To enable the control box to be installed, to remove the clash, the control box was required to be mounted lower. So a bracket was designed on site with a sketch and manufactured. I haven't got a copy of the sketch, unfortunately, but it was a good sketch. There's a little CAD drawing there. The structural calculations were then carried out to confirm that the bracket was suitable for did the FEA analysis to show that it was structurally sound. The new brackets were installed, which lowered the control box adequately enough to enable the connector to be fitted, and also kept the box within the shadow of the AdBlue tank. So it's all about trying to use that space envelope that we already had existing. So it just shows how problem solving sort of went on during the week. There was nothing that stopped the team of people that were working on this unit. It was they all had a can-do attitude. It was brilliant. And this is the last of the upgrades rather than issues that we encountered, shall we call it. So due to an issue with the fitment, we had a few options to fix an issue with the sight glass and sensors fitted to the hydrostatic tank. So we had three options really. It was sort of a you can do almost now a mid-term and a long-term option. So the first option was leave the sight glass where it was and provide a label to indicate the fluid levels. So this would be a label on top of whatever was existing to show where the fluid level should actually sit. A new float switch adjusting the low position, the low warning positions. This is the low oil sensor, not the low. The lead time for that was approximately 3 weeks, and that was all around getting these new float switches. I think it was from Germany, if I'm correct. Yeah. Option 2 was to move the sight glass up with the use of an adapter and provide labels again to show the various fluid levels. This is more the min and the max. A new float switch adjusting the low warning position again would be the same switch as discussed before, and the lead time for that was 3 to 4 weeks, again around the new float switch, and gaining that from Germany. And the third option was sort of a if we had unlimited time and this unit could stand for a longer period of time, we would have a new reservoir which would come with a new sight glass in an altered position, labels obviously already fitted to that, a new float switch adjusting the low position, and that was 6 to 7 weeks, which would have possibly been even longer. I think that was quite ambitious. So now we get on some shiny photos. So this was photos taken on the week commencing the 8th of March. So this was on, I think these photos were taken on the second week after absolutely everything was fitted and shiny and polished, but before it managed to go on a proper test run. So as you can see there are the exhaust underneath the U sort of shape that Ian spoke about. On the right hand side, we've got the new hydrostatic tank. On the left hand side of that, you can almost see illuminated some of the lights. The fault light's not illuminated, which is good, and the low sensor at the bottom of there. And on the right hand side of those, sorry, on the one with the blue label is the AdBlue. On the right hand side of those is the hydrostatic tank. So I'm going to hand over to you now, Louise, if that's okay, to play the first of the videos. Is that okay, Louise?
No, she's not nodded off.
Here we go. Appear to be missing sound again, I think. I think it's possible if your microphone's muted or missing sound, Louise.
I'm very. I had sound. Did everybody not have sound?
No. If you could give it another go with your sound not muted, it might be.
Okay, let's try it again. Go straight back to it.
If you hit the forward button, it should work.
Being thwarted by the technology tonight. I think probably best if you continue.
Yeah, that's fine. I'll
stop sharing.
We'll find a way to show you the.
Yeah.
Show you at the end. Is that taking my screen back to where it should be in?
Yes, it has.
Yeah.
Brilliant. So that was the video. We'll probably show it somewhere later on, of the vehicle moving out at the end of, I think that was Friday, was it not, Ian? With all the gear attached.
It was, yeah.
Yeah, so managed to get a driver to take it out, put it under load, get the compressor going, make sure there was no hydrostatic oil leaking anywhere, and get a little bit of publicity photos. So next slide. So this was results day one. 98% reduction in NOx. And the vehicle needed to be planned to be timetabled, which was an issue that we had as well. Obviously, the demand to get the vehicle back and with all of the equipment fitted was stressed heavily upon us upon delivering the unit back. I think it took us a little bit of effort to try and get that unit diagrammed. We had a lot of issues with vehicle availability. So I think an initial 98% reduction in NOx was the right way to go, at least. And then Ian's managed to grab me a better slide. So I think this was 30 days of testing. In the report that you can see, I think it was a 77.65 NOx conversion and a huge 96 kilograms worth of NOx removed, which is absolutely massive. This is taken from data that we get live, or we have the ability to get live from Eminox. So it gives us a great estimate of the vehicle's health as well. Is there anything you want to talk about on there that I might have missed, Ian?
Yeah, I'll just explain a bit about if you look at the chart on the left, the blue and orange bars. The orange bars represent the percentage NOx reduced. If you look at the scale on the left, that is a percentage scale. Whilst the exhaust gases are in excess of 220 degrees, that's when the SCR can function efficiently. Anything below that, you get a very rapid tail off in NOx reduction. So the blue bars show the overall percentage of NOx reduced through the whole of the run for that day. So that will include periods of idling or coasting when you'll get a significant fall off in SCR temperature, exhaust gas temperature. So, but overall, we got some very, very good results, as Nick said. An average high 70s is excellent for this type of technology. So we were very pleased with it.
I'll let you talk about the future and development.
Yeah, just obviously with every good thing, there's a bit of a price to pay. And one of the disbenefits of this equipment is an increase in back pressure. We put in some substrates in line with the exhaust, where it was clearly just open to air with a few baffles maybe in the silencer, but we are putting in some obstructions, and inevitably we're going to get a rise in back pressure. And unfortunately that results in temperature increase in the engine and puts some additional stress on some of the components, particularly a turbocharger we found. Now, this is from another project we've been running on a class 159 down on Southwestern. We found the turbocharger has suffered quite badly as a result of that, and also the exhaust valves as well. So what we're looking at doing is, well, with our partners at Eminox, is we've created an improved design with a greater diameter and a smaller pore size for these substrates to help reduce that back pressure. And the modelling, CFD modelling, is showing that is going to be in the region of 25%. Whether that's going to be enough to convince the engine overhaulers that we're not going to increase the risk on components between overhauls, and therefore will they support it with a warranty is something we're in discussions with LH Group, but it's something we're reasonably optimistic we'll be able to overcome. But that's an ongoing piece of work. And to accommodate these larger substrates and increase exhaust after treatment system, we're looking at options for redesigning the CET tank, which is adjacent to the exhaust on a Turbostar, just to try and free up some more space to accommodate it. As Nick mentioned earlier, there's the hydrostatic oil tank side glass needs to be optimized both in terms of its length and its position to give operatives better visibility when topping up the tank and looking out for any rapid reduction in oil level. So that's another piece of work that we will take forward should this go forward into a production phase. The Dpf Life Assessment is something that is quite advanced from our trial down on Southwest, and that project's been ongoing for over 2 years now, and we've got a lot of data from that. What we're seeing is that the Dpf is typically changed between 3 and 6 months. It obviously has to fit around the existing maintenance regime, typically on a B exam or something of that size, so you've got time to change this out. But one of the options we're looking at to extend the interval of change out and the life of a Dpf is using low SAPs or sulfur content oil. The problem with sulfur in oil, in the engine oil, is that when it burns, it creates ash, which deposits on the Dpf, and sort of rapidly can lead to a significant shortening in its life. You can't regenerate the ash; it just sits there, and any means of reducing it is obviously beneficial. But there is a price to pay in that low SAPs oil costs quite a bit more than the normal oil. So that's something that we're assessing right now. Another issue with this technology is that long periods of idling, which, as we all know, we often see on DMUs and any diesel unit on depot, it can cause the Dpf to block over time and can cause quite a spike in back pressure, which can lead to significantly higher temperatures than they would be normally experienced, and accelerate component degradation. So what Eminox have been doing with their partners in the telemetry, as their telemetry contractor, is to put an automated alert in place so that any spikes in back pressure can be picked up immediately by the operator and corrective action taken. I've already mentioned the warranty discussions with LH Group, and another issue we need to consider is that on some of the heavier turbo stars, we may be pushing axle loads quite closely with adding this extra mass on. So we need to do some work on that and understand what further mitigations we can put in place if necessary to to ensure we continue to comply with the standards. So that concludes the presentation. Are we going to run the videos now?
I've got this video, which I can't play, and then just as a parting line, I was just going to say, thank you to the amazing team at Eminox, Bosch, Porterbrook, DG8, from myself and Ian. It was a huge success, and without those and with the challenging timescales that we were given, we wouldn't have been able to complete, I don't think.
No, I second that. It was a great team effort by everybody involved.
We'll try and get the videos, I think.
Are you going to give that a try, Nick, or do you want me to?
It definitely won't work with my sound. It did work with yours earlier.
Okay, let's give that a go then. So,
if not, they will be part of the presentation that gets sent out.
Quite so. Okay, here we go. My microphone is clearly on this time.
To retrofit exhaust after treatment technology to a midlife train to see if we can bring the emissions levels down in line with what you would expect from a new engine. And an opportunity arose with an organisation that's part of the Department for Transport called Innovate UK. And we've collaborated with East Midlands Railway and the main contractors, Eminox and Bosch Rexroth, in delivering this work.
Effectively what it does is it works like a catalyst converter, very similar to that of your car. It reduces the noxious levels from the train.
And what we're doing is using AdBlue to react with the nitrogen oxides in the exhaust system via a catalytic process to remove that nitrogen oxide and replace it with harmless nitrogen and water.
What this means to the business is our working environment within our depots here is a cleaner, safer place to work. We have less noxious particles. It's also very good for our customers of the fact that when these are in enclosed stations or slightly covered stations, again, the fumes and the emissions are far lower than they are currently, which makes for an overall greener approach to our sustainable railway. What the trial actually proved was that the Eminox equipment, the new hydrostatic tank, the AdBlue system would not be intrusive of the normal operation of a train. Therefore, the trial has proven that the systems we've included here does not impact the maintainability, the availability, or the reliability of the unit going forward.
And then I think the other one's at the top right hand corner of your screen still. There. Thank you. So there's nothing on the first unit. The first group, sorry. And there we have a nice new exhaust system. And the hydro and AdBlue. And that was the on the end of the first week. Thank you very much for that, Louise.
You're welcome. Unless anybody wants to watch Sean Locke, so I'm not going to press the next go button.
We've been together a long time.
Ah!
Quite a long time.
Technology again. Thank you very much, Nick. Thank you very much, Ian. So can I invite everybody back into the room? You'll need to reactivate your videos if you want to see some smiling faces. Personally, I think smiling faces are much nicer than just names. I remember some of you. I don't know all of you, so it'd be much nicer if I can see real people.
Mr. Thompson, nice to see you.
That's good. So it's question and answer time. So I'm sure frankly, that was a proper engineering lecture. So with some proper engineers in the room, there ought to be some proper questions coming from the floor. So if I could ask you you can use the buttons that you've got to raise your hand, or if you want to, I can scroll through the different screens and you can wave at me physically to say I'd like to ask a question. I can see Richard waving his hand first of all. So Richard, Richard Gibbon, would you like to go first, and then anybody else to line up in the queue behind Richard?
Yes. Can you hear me?
Yes, we can.
Right. Okay.
Is that your question?
Please
Go ahead, Richard. Sorry.
Oh dear. Can you please explain what urea is and how the AdBlue affects the actual exhaust behaviour? I'm sorry, but I don't get what happens, and I'd like to know what's happening inside the catalytic converter.
Yeah, that's fine. Urea it's actually pig's urine that is AdBlue. It's a urea solution. It's watered down significantly, but the ammonia within that solution, in the with the catalyst and at that temperature, what we're seeing is the catalyst will kind of facilitate the reduction of nitrogen oxides by reacting with the ammonia. So we end up just with nitrogen and water from that process.
Thank you. Perfect. Thank you very much.
Okay.
Well done, Richard. Good question. And remember, the only stupid question is the one that nobody's prepared to ask. So don't worry about it.
Urea is highly soluble as well.
Excellent. Derek, off you go.
You're on mute, Derek.
Come on, Derek.
Hang on a minute. We'll try again, Derek. I'll
on mute, Derek.
ask you to unmute. That's it.
Okay, we're there now.
Yep, try again.
The question was, is it cost effective? Nobody's mentioned anything about pound, shillings and pence, as it were, at the moment. And I'm just wondering, obviously going to cost quite an amount of money to actually fit this, but is it at the end of the day considered to be cost effective?
That's a very good question. And it's one we haven't quite got the answer to, but I can tell you that indicatively to fit a vehicle with this equipment would be around £50,000. There's obviously an operational cost as well of the AdBlue and the maintenance, but we think it's a cost-effective solution to cleaning up midlife and older vehicles, as opposed to fitting a new engine. And I think we can all appreciate the costs that come with integrating new engines into old trains, and that's, you know, the non-recoverable engineering costs up front are going to be huge for that, and new engines are not cheap either. So we think it's got legs potentially.
Thank you.
Jolly good. And I think one of the other key points on that, Ian, if I may, is that you've got to bear in mind what you're comparing when you're saying, is it cost effective? So is it cost effective? Just to the question, straight direct question about, is it cost effective compared with a new diesel engine, is a very good point. But we've also got the broader context of how well does that new engine fit into the existing vehicle? What's the life of the vehicle left? And we're not going to be able to electrify everything in the pace that we might want to. So we have to make diesel vehicles last for as long as they can. And that's actually quite good from an embedded carbon perspective more broadly. So you've got to think where you draw your scope boundary when you ask that kind of question, and take into account the broadest kind of scope.
Exactly. I answered the question in the context of alternatives to reducing that, but I think if you look at it from the benefit of removing these emissions for the country, for the health of our population and the workforce and travelling public, it's difficult to measure that. But I'm sure that there will have been some studies done on the harmful effects of NOx and particulate matter on people. I think that's coming more into focus. And if there isn't any clear data now, I'm pretty sure there will be quite soon. And although we in the railways probably contribute relatively little in the overall scheme of things to the pollutants that go into our atmosphere, I don't think it's acceptable for us to do nothing with these emissions.
Can I ask, when you talk about,
if I can just say, there's the first formally recorded death due to air pollution happened earlier this year, little girl in southeast London. So I think we're seeing more and more of that. Bob, you want to ask a question? Bob Lovett.
thank you. So when you say for midlife engines, and I get the point about you don't want to have to go around replacing lots of them, then how long would you anticipate those motors would carry on working? How many years? 5, 10?
I would expect them to continue working for the remaining life of the asset, the Turbostar. I think what are they now? 20 years old, 21 years old for the earlier ones.
They are somewhere around half-life.
15 years or so. Yeah.
Right.
Similar to what we've seen on the 15Xs. Those Cummins engines are still running, obviously overhauled, but they are essentially many of the same components, same blocks. They're still running 30, 35 years into their life.
So saving that, cutting down the emissions for that period of time, every little helps. That's quite a lot, really, if you add all of that up.
It does get to the point where we have penalties put against us for not reducing environmental impact and the carbon footprint that we have as an operator as well. So it's sometimes the answer doesn't really matter about the cost. We just have to do it, as Louise said.
Yeah, and the carbon values are set by BEIS in this country. That's the Department of Business, Environment, Innovation and Skills. And there's been a huge hike in the cost or the value of mitigating carbon between earlier this year and the start of September. And that's making quite a difference to how, certainly the business I'm in, that's making quite a difference to how we can value the worth of mitigating carbon rather than just emitting carbon. It's a huge change. I can't remember, I think it's average is sort of 3.5 times higher than it was the day before over the course of, say, 20 to 30 years. So that's a huge amount. Right. Andy B, you've got your hand up.
It was a question on why you'd tried to do all the fitness in 1 week, when obviously you've planned this job for months and months and months, and not only in 1 week, you did 2 significant changes both at the same time.
So it's down to availability of the unit. So the unit it's cascaded from another operator from West Mids, I think that one came from. And we had a 2-week window before the unit was going to be reliveried. And then it was required for service. So we had a 2-week window. So whether it was going to take 17 working days or not, we had to condense that into 2 weeks. So we gave ourselves a 2-week window. We had slippage because the unit wasn't delivered to us when it was supposed to the previous week. So we then basically had a 1-week window. So it had to be done during then. If it wasn't done during then our 9 months to a year's worth of planning and materials cost, Ian's cups of teas would have been for nothing.
Right. No, okay, I understand, but yeah, so it wasn't by choice.
No, ideally a 2-week window when the vehicle is there, it's ready. Ideally, if we encountered a few problems. We'd asked for the unit to be drained of hydrostatic oil and the hydrostatic tank to be removed, which would mean that operations for everyone else would be easy. What we then encountered was, if we did that, what we're going to benchmark it against. We need to have hydrostatic oil in the hydrostatic system as it currently existed in that exact vehicle to be able to do the load under testing, to be able to then say at the end of the week, this is what it was, this is what it is. Even if we'd have tested on the vehicle next to it, it's not a like for like. There would have been some discrepancies and the results would have been for nothing. So we're really, really lucky that it was delivered late and those two things didn't happen.
No, it's well done. Hell of a lot of work in 1 week.
Thank you, Andy. Appreciate that.
It's really good. Right. Come on, we've got some proper engineers on
I think
this.
Richard's had his hand up for a while.
Which Richard is that?
Mr. Lewis.
Richard Lewis. I apologise for not seeing you. Richard, go ahead.
That's fine. All I was wondering is, are there any plans to put them onto something like a 150 or a 158? Forgive me if this was answered already. My screen dropped out earlier.
I think the first one was fitted to a 15X.
Yeah, it's a 159 operated by Southwestern has got one vehicle has got this equipment fitted to it. And that's been running around for about 2 years now, so we've got quite a bit of data from that.
I think some of the 15X units are further along the almost lifed vehicle rather than midlife as well. So you've got to look at what you're going to get out of fitting that much money's worth of componentry to it if it's going to exist for only a couple more years. I know most of ours will be gone in the next 2.
Okay.
Thank you.
Can I claim chairman's privilege and ask, do we have any thoughts on the potential to scale this up to bigger engines?
You're talking about diesel locomotives. Yeah, it's more difficult on a 2-stroke engine to get this system to work as well. It's not. It's something that is being explored by Eminox, and there has been some interest from other parties in the industry. I'm not at liberty to say who, but yeah, it is something that it could be done, but it's more difficult because of the 2-stroke arrangement and the limited space you often find in Class 66, for example.
Yes, there's a surprisingly large amount of stuff squeezed into a very small space on those locomotives. Yeah. Okay. Good.
Samuel's got his hand up.
Ah, yes, thank you, Sam.
Thank you. Following the recent RSSB report into air quality and the interaction between exhaust and HVAC and some of the interesting results that's generated, have you considered running a similar experiment with the after treatment on the 170s?
It's something we're aware of, Sam. We've not got to the stage yet of making any plans to do that, but it's something that we are considering the results of that report, the outcome from that report, and there may be something that we will take forward. At the moment, though, we've not got any firm plans to do that, I'm afraid.
Okay. Right. Nick.
Sarah's waiting.
Sorry, Andy.
Sarah's got a hand up waiting.
Oh, has she? Oh, yep. Sorry, my screens keep moving around. It's difficult to keep track of who's where. So please go ahead, Sarah. You need to unmute yourself before you start.
Thank you for reminding me of that, Louise. Aside then. Yeah, I was just wondering that with your U-shaped exhaust, of course, that it makes the back pressure conundrum a little bit worse. And also, I was just wondering, did you suffer much with deposits through injecting your urea? Did you have any urea deposits and things to deal with? And how was that all with your sort of research? Did you do CFD on the mixer and all the rest of it?
Yeah, so Eminox did do extensive CFD on the arrangement, and what they do is the control system is very frugal with the urea injection. It always slightly goes under, you know, and it can be tweaked manually to adjust the injection level, the percentage. Typically, it's around 6% of the fuel consumption for AdBlue injection. But what Eminox tend to do is start off low and bring it up to avoid these deposits that you mentioned there. They can cause havoc both in the delivery system to the EATS equipment in the urea pipe and in the system itself. So we've not seen any of that though, and we are satisfied with the NOx conversion we're getting. So I think we've probably got quite lucky with the initial setting. It's just finding that sweet spot between, you know, not putting in too much and also managing to get the NOx reduction that you're targeting.
That'll be the new challenge in reducing the back pressure, I suppose, because all these parameters are going to change and have their effects, aren't they? Yep. I was also thinking, of course, with the increased back pressure and looking at costs and things, and I know the overhaulers and you know, operators are always interested in your back pressure versus fuel consumption analysis as well, because obviously, you know, they don't want to be running at a higher fuel consumption with a higher back.
No, that's right. We haven't noticed any significant change at all in fuel consumption on either this vehicle or the South Western Railways vehicle.
Something that we never touched on as well, we didn't suffer with performance either. So the whole idea of fitting this was to have at least as good a performance as we currently had, and we haven't suffered with any less performance.
Good. Well done.
Great question.
Jolly good. Sounds like a win-win all round, really, which is what you really want from any kind of project. Okay. Any more? We've got a few more minutes for questions, so if there's something that you'd really like to ask, or even if you're not sure about, just ask it anyway. Who's hiding around the corner?
Was the hydrostatic mod simply to make space for the AdBlue tank, or was there another reason for the hydrostatic mod?
It wasn't primarily for that reason. That was we needed to find space, Andy, to put the urea tank. And we saw an opportunity to significantly reduce the size of this tank using the hydraulic tank, or using the new technology that Bosch had brought along. To qualify for Innovate UK funding, you have to show, obviously, as the name suggests, the right level of innovation.
Yeah.
And I think to meet the criteria, we needed to do more than just put in some more EATS equipment, which had already been done on a 159. And we were able to demonstrate sufficient levels of innovation by adopting this much lower volume tank. And another novel feature of this was the U-shaped exhaust after treatment system as well. Never been done on a railway vehicle, to our knowledge.
Okay, well, thank you.
Well, an 84% reduction in oil, if I remember you correctly, is worth having at any time.
Definitely.
Mr. Skinner, sir.
Richard's just said that Andrew Skinner had his hand up. He's written it down on a piece of paper.
Did you have your hand up, Mr. Skinner?
Mr. Skinner.
Indeed, it is true. I did have my hand up, but I was going to try and probe the question around the U-bend and back pressure, which I think we've exercised. But while I've got the airwaves, just to say thank you for letting in an interloper from the Southwestern Centre. But I think this does extol the virtue of virtual or hybrid meetings.
Here. Well,
so thank you for letting me in.
You're very welcome. We're going to give hybrid a go probably in the early part of next year. With the Scots have been giving us some tips. So we're going to pick up on that and give it a go, assuming we can actually get into somewhere physical in the first place. So here we go. Right. Any more for any more?
We've got Sarah again, I think.
Sarah, go ahead.
I was just wondering, you know, you did really well with the NOx conversion on peak and average rates of NOx reduction. You're talking about the SCR being really only effective over 220 degrees C. I was wondering if you'd had time to do any work on looking at the duty cycle of that vehicle and seeing if there's any sort of, you know, limits or anything where you're thinking that if you hadn't had that duty cycle, it might not have been so favourable?
I think what we saw was when the unit went into passenger operation, we started to get some slightly better NOx reduction levels, because just by the nature of it, you know, it wasn't like on earlier. It was been used for driver training. We were getting a lot more standing and idling. But in passenger service, it was working a lot harder. It was on some longer runs, and you know, consequently the exhaust gases were much higher. So we got much better conversion. But it's a good point. There are certain duty cycles that this technology is more effective under. But you can't change the train to run just to suit the technology. I think the challenge is to get the technology optimized to, you know, to what the train needs to run under.
Yeah, that's what I thought, really. Yeah, that's it. You know, the train does what it does, but you might say, well, we couldn't, you know, think about installing this technology yet on such and such a service or whatever in such and such an area, because, you know, it's not going to be successful. But I don't know if anybody's had time or the data to do that.
It's a little bit early in the trial for that, Sarah, but it's something we will be looking at. Yeah, and feel free to email me if you want to, you know, or I can get in touch if you want to get the results of that work in due course.
Okay, thank you. Thanks, Ian.
Jason McAndrew.
Yeah, Jason, you've been patiently waiting.
Yeah, hi, no worries. Well, thanks very much for a great presentation. Simple question, really. It's just, how have you found the interval that you have to refill with AdBlue? Because the other thing is, do you ever end up in a situation where you run out? And I do know, because I've got a dirty diesel car, that if I run out of AdBlue, I can't drive it. Is there anything around that?
So this is similar to a car, but dissimilar to a car. Without AdBlue, it will still run. It just means that the conversion doesn't take place, and obviously we don't gather enough data. Thankfully, we have AdBlue at both of the depots where this runs to. So that's Eastcroft and Etchers. They both have AdBlue tanks, and I think one of them has the filler. I think the other way of filling it is just a funnel, basically. But we try and fill the AdBlue at the same time as tanking the train, so it shouldn't really ever get missed. That shouldn't.
We've got the fillers at both sites now, Nick.
Yeah, it's fillers at both sites now.
Cool. Thank you very much.
So good attention to maintenance process, as well as the hardware and software and the technical stuff. It's just as important in the project.
We'd had to jump through those hoops before we'd fitted it.
We don't want to make the depot's life any more difficult than it already is. So that was a key part of the project, just to give them everything they needed and to have, you know, minimum impact on the day-to-day work.
Make it opaque, as if it's not there, if possible, especially to the drivers.
Yeah.
Any further questions? Well, I have to say, for my personal thanks, that was superb. We had a proper engineering lecture with drawings, details, and all sorts of things that were thoroughly and properly explained. So thank you very much. Stephen, I think you're going to do the vote of thanks.
Yes, thank you very much, Louise. Ian, Nick, great to see you again, Nick. Great to make your acquaintance, Ian, and thanks so much for this evening's lecture on behalf of the North Eastern Centre. Although it's great to have buddies from literally the other side of the country. We've got about 50 attendees here tonight. So you've had a good audience, and you've certainly delivered a fantastic lecture for the audience. We've had mechanical engineering, electrical engineering, systems engineering. We often get those kinds of mixes. We don't often get chemical engineering involved in the mix as well. So, and when we've got someone like Richard Gibbon asking questions about engineering, we know that we've got a good subject on our hands. So the technology's there, and we're all kind of familiar with this. So if I can just hold you all to account and say, I've got a tip. If you ever need AdBlue for your car, go to the local farmer's merchant rather than buying up the forecourts. They've normally got a filler and it's bloody cheap. So there's a little tip you get from this evening as well. But yeah, it's technology that we're all sort of familiar with. You know, we've all been back to our dealerships to try and get our AdBlue and Dpf sorted out, and they weren't regen properly. So we all sort of sucked through our teeth when we saw the presentation and thought, oh God, this could be any sort of problems. But Ian, you used the words, we got lucky. I'm a firm believer that you make your own luck. And I think you've had an excellent project delivered very well. It certainly seems to have ticked all the success boxes, just like this evening's lecture has ticked all of the success boxes. So thank you ever so much. If I can ask the audience, we would normally give a hearty round of applause. Half of you muted. There's some little caricatures at the bottom, so you can give thumbs up, you can give a round of applause, you can give a celebration party popper, or you can come off mute and join me in a round of applause and give a hearty thanks for the presentation we've had tonight. We've been educated, and that's why we attend IMechE lectures, and that's why we work with the institution. So on behalf of the North East Centre, thank you very much, Ian and Nick.
Yeah.
I'll pass you back to Louise, who can tell us about our next event.
Thank you, Stephen. So if I can just revert to my screen for a moment. So we will have, when I get the technology in action, our next meeting is on the 9th of December. It is our Christmas film evening. So normally I would say we'll have some mince pies and oh, for goodness sake, Louise, get it right. Present, not share. There we are. So we would normally have mince pies and a raffle and some nice sandwiches, and everybody would be very happy and chatty. We did this last year with the Yorkshire and North East Film Archives. I had a brilliant evening with Derek and Richard providing some additional commentary over and above that which the archives could provide for us. So as before, we'll do this on Zoom. Please share this with your friends, because I know a number of people, not just in the North Eastern Centre, like the opportunity to see films, but it will be focused on the region that we're showing on the screen, and usual booking arrangements apply. After that, we're going into January. We'll be hearing from Graham Taylor about the CAF Mark V and Caledonian Sleeper vehicles and their introduction. If I have my fingers crossed, I have my toes crossed, I have my legs crossed, it will be in person. If it isn't, we'll keep you posted. But if you could book through tickets and the ticket source, that's the quickest and easiest way of us keeping you updated once you've decided to come. So please tell your friends and tell us if you'd like to see or hear something different than we've got on the programme normally. At which point I'll stop sharing that and say, as ever, stay safe, please look after yourselves, stay in touch. There's several ways of doing it, as we showed earlier. At the very least, just go to our Near You page and you can drop us a line, and then we can get more advanced ways of engaging with you still. And if you'd like to become involved in actually helping us run the North Eastern Centre, then the opportunity to do that starts from about April next year. Always interested to hear from people who've got either a contribution to make directly or would actually help us like to help us run these events, because we're all busy people, we've all got full lives, and so the more hands that we can have to help us do this, the better. Have I forgotten to say anything, Richard, or have I covered it all? Jolly good. Right, in which case I wish you a pleasant evening. Look forward to seeing you on the 9th of December and definitely in January for that lecture. If we can hold that in person, we will. Otherwise, thank you very much again to both our speakers, to Nick and to Ian this evening, and to look forward to seeing them hopefully at some other lecture of ours in the future. Otherwise, good night, everybody, and take care.
Thanks very much. Good night.
Right, everyone.
All right.
Thanks, all.
There's some more decarbonisation for everyone tomorrow night.
Yes. It's going to keep coming back, Andy.
Network Rail's IMechE lecture at Milton Keynes Centre.
Oh, right. I didn't realise they were doing that tomorrow night.
So yeah,
I didn't pick that one up.
So
yeah, well done then. That's going to be a challenge.
Yeah.
Decarbonising those yellow machines.
That's got two massive, great big cat engines in it that are really dirty and horrible.
Well, I'll look forward to seeing that. I shall drop Tom a line and say, watch out, here I come.
Yeah. Well, that used to be I used to be the fleet manager of that vehicle.
That is a virtual one, or is it a real one, Andy?
That's the RM900 ballast cleaner.
Right.
So there were two dirty, great big American cat engines in there.
Yeah. Where's it based still?
There's 3 in the country, 4 in the country, in different areas, different geographical areas. I'm not sure which one that is.
I'm not sorry. It's.
But yeah, that's tomorrow night. So more decarbonisation tomorrow night.
Excellent. Right. Thanks very much, everybody. I'm going to stop the recording.